Ladies and gentlemen, dear colleagues, let me to open the session 2 called Nutrition Value of Silages and Precision Farming and Feeding Near Technology. The first lecture will be from Dr. Menšík from Jevičko. That's yours.
Thank you very much, Chairman. Dear ladies and gentlemen, my name is Ladislav Menšík. I am from Crop Research Institute in Prague, and let me introduce with my colleague from Mendel University in Brno, Professor Mrkvicová, Professor Pavlata, Professor Doležal, and colleague Václav Jambor from company Nutrivet, theme about development of calibration equation for monitoring the quality of sorghum forage. On the picture you can see content of the presentation. I will tell about sorghum, quality of agriculture crops, and NIRS instrumentation. Agriculture practices in the past and present years places high demand on the quality of agriculture crops, raw materials, as well as voluminous feedstuff. Classical analytical methods may be wet chemistry, accuracy and sufficiency reproducible, demanding of staff working, and a long time determine the result, and in present financial means. And new modern tools for measure of quality of forage is near-infrared spectroscopy. What is near-infrared spectroscopy? Near-infrared spectroscopy is analytical methods for the identification and structure characterization of organic compounds and determination of inorganic substances. Near spectra contain information about major chemical bonds, maybe carbon, hydrogen, oxygen, hydrogen, nitrogen, hydrogen. And molecules where in our structure have hydrogen will have measurable near spectrum, and we need for suitable for near analysis. Sorghum. What is sorghum? Sorghum is now globally important cereal crops, and in world cereal crops for grain. But sorghum is for forage production and have many outstanding characteristics. High biomass production, high forage quality, acid detergent fiber, organic matter digestibility, high drought tolerance, and high nitrogen use efficiency. But there is problem. Problem in world literature. Very small little information about near-infrared spectroscopic calibration models to predict sorghum forage quality. Maybe color proteins, organic matter digestibility, etc. On the picture you can see two studies, old, maybe 1989, 1998, about best regression coefficient about 0.9 for color proteins in sorghum silage, acid fiber, nitrogen detergent fiber, and in for green crops, very high coefficient of regression, determination coefficient 0.9, 0.98, very high regression for crude proteins. The objective of the study is to present the development of calibration equation to predict forage quality parameters in dryland green biomass samples using near-infrared spectroscopy technique in one cutting of grain sorghum. You can see grain sorghum in our research plot in Ivanovice na Hané. This is area picture of our grassland research station in Jevičko, where we have tools for near-infrared spectroscopy. Material methods. In our study, we have grain sorghum hybrids, which planted on long-term research ecosystem plots in Řiháček College of Mendel University in Brno, and we measure on near spectroscopy dried and standardly grown samples of whole sorghum plants. We have 454 samples, and samples we have in calibration set and independent validation set about 84 samples. Standard laboratory analysis were in Mendel University, crude protein, fiber, fat, acid, detergent fiber, organic material stability, etc. In literature in Czech and European, maybe in future, inward. And you can see it is our equipment for measure near-infrared spectroscopy, Fosnir system 6500 instrument from USA. It is first tools in Czech Republic. We from 1995. It is 28 years old equipment, but measure is very well in same time now. Samples we measure in smaller ring cups into parallel replicators in visible and near infrared region. Scanning step was 2 millimeters, and very important is software for develop calibration equation, and we used partially square regression and modify partially square regression. Is very modern method for regression for calibration in near-infrared spectroscopy. On the picture you can see scheme of measure on NIRS. You can see sapling of forage. In future, our project silage of sorghum, sample preparation, deing, milling, and standard laboratory analysis and NIRS analysis. You can see 455 specters of samples of sorghum, and in data processing, calibration, and validation. This is a picture about our research plot in Boskovice near Jevíčko. We have small long-term trials with sorghum, and we have big research plot in agriculture company in Czech Republic, in Boskovice, maybe in Czech, Malá Hana, and you can see my daughter were feeding of sorghum silage in cow house. And first picture is about result from crude proteins. You can see coefficient, determination coefficient is about 0.99. You can see 99 of points fit the regression model, and validation model have very nice correlation, maybe coefficient of determination 0.91. Second fiber is very big regression, maybe 97% of points fits the linear regression model, and methods we used modify partially square. Validation set have regression determination coefficient 0.94. Parameter fat is horrible, maybe coefficient of determination may be 0.81, 81% of point fits the regression model, validation may be 0.72. Neutral rectangular fiber, regression rebut may be 97%, very nice correlation, and regression model in NIRS technique. Validation is very good, 0.91. Acid rectangular fiber is very good, regression coefficient 0.96, 96 points of measure fits the regression model, and organic matter digestibility is very good. Regression may be 89% fits the regression model. And now, conclusion, near spectroscopy is modern tools for measuring the quality of the sorghum forage in parameter where I presented high regression coefficient and coefficient of determination. Measure techniques is very fast. We measure samples maybe 2 minutes, and result we have maybe 10 minutes. When we have in tools calibration model with independent validation, and nearest techniques maybe determine the different components of materials forage under analysis from only one sample measurement. We predicted crude proteins, acid rectangular fiber, organic matter digestibility only with one measure samples. Precision regression modeling using modern statistical multivariate methods modify partially square, very good result for prediction of forage quality parameters. And robust calibration model of prediction quality of forage represent high potential of future management and control of forage harvesting in sorghum and selling. And please, thank you very much for our Ministry of Agriculture, Czech Republic, in project of Ministry of Agriculture and joint research project with College Mendel University and Václav Jambor company of Nutrivet. And thank you very much for your attention with pictures from Boskovice furrow, where we tested, planted sorghum in Czech Chirok for 2 cuts in Malhana in agriculture companies. We planted sorghum, but we cut it 2 years per rock. Yes? Thank you very much. Excuse me, my English is horrible, but excuse me.
Thank you very much for an excellent presentation. Any questions? While you're thinking about it, I have one. What are your plans on keeping the prediction model up to date with new samples over the coming period?
Excuse me. I don't understand the questions. Maybe.
So next year, will you do more modeling samples through the system to ensure the calibration is updated on an annual basis because of changes that might occur because of environmental changes?
In our project with my colleague from Mendel University. We measure forage quality of sorghum in standard laboratory method and in near-infrared spectroscopy. And this result was from only one cutting per year. But we, in our research, have a system for plant sorghum in 2 cuts and measure quality too by standard laboratory and by application of near-infrared spectroscopy. And develop of equation is very difficult for quality parameters. And we need very much samples for best calibration.
Thank you.
Yes, okay. And in our research about sorghum, we measure maybe 2025 years, and maybe just 3 years we measure and plant it in sorghum in Malahana region.
Thank you. Any other questions?
My question is it possible to transfer this model to other hardware from NRS spectroscopy? Maybe I think there's a difference between types of spectrometers, yeah? And maybe it's a question if your model is well fitted for this FOSS equipment. Is it transferable to other equipment?
Yeah, it is very difficult, very difficult problem because nearest tools from different companies have different results, but in world exist libraries of spectra, and in world exist programs for transformation of spectra from different equipment tools for future calibration, because it is maybe local calibration, but in future research we need global calibration for big areas, maybe no Czech Republic, maybe countries about Austria, Poland, Slovakia, Germany, etc. This is only calibration model local, and global is in future research. Thank you.
Any more questions? Thank you very much.
Thank you.
So we would like to apologize about changing, because Sylvia Orosz and Dr. Illek asked us to change the lecture. So I would like to ask Sylvia Orosz from Hungary for his speech.
Thank you, Chairman. Okay. So we have 2 presentations now. The first will be a little bit longer. Sorry for it. Okay. So I will have 2 presentations after each other about the corn silage and the CSPS, the processing score. The first presentation will be a little bit longer. Sorry for it, but there is a special message at the end of my presentation, and I would like to share it with you. And after I will continue with the CSPS, the processing, the technical point. Okay, the corn silage. I would like to show some data about Hungary. We have rather large farms. The average is 450 cows on a farm, so generally we have 900 cows and heifers and calves on our farms. And we have relatively high milk yield. We are above 10,000 kilogram milk per lactation. So we have an increasing tendency in milk yield. Unfortunately, our reproductive performance is poor because the calving interval is more than 400 days. It is awful, it is disastrous, but we would like to help, and the forage we would like to decrease it, and the forages will help us in it. And the calving, and the average lactation number is also rather low, 2.1. It's very similar to the United American model. But we would like to improve that one. And what happened during the last 50 years? For many years, many decades, we used corn silage and Lucerne silage, haylage, and some hay. But the actual situation is absolutely different. Just, you see on the slide, there is a puzzle system now. We have still corn silage. We would like to work with corn silage, but we have additional crops to strengthen the corn silage, because the corn silage is in danger in dry continental region in Hungary, and I would like to show it why. So, and I would like to show that we have almost 60,000 hectares of whole crop early cut rye in Hungary. So the double cropping of rye and corn silage is very typical now, and we have more than 10 years experience. So it is our present. That is a living present that we are working with double cropping. Okay, and what happened in our dairy industry? We had an increasing milk yield, as you see here, and we had in the past an increasing calving interval. What does it mean? That the reproductive performance getting worse and worse with the higher milk yield. But there was a point when we changed the trends, and now we have higher milk yield, but better performance, reproductive performance. I think we can be proud of it, because it's not general. And when happened this change? It happened generally, as I see, 2010, 2012, and it was the time when we introduced the double cropping, the rye and the corn silage, the grass and the corn silage. So the forage type has huge effect on milk yield and animal health also. But the double cropping has other importance because of the climate change. What is happening if we look at the other side, not the animal side, but the weather? So we have more and more hot days during the summer in all around in Europe. And we have mild winters. So not just the summer is a problem, but the winter can be a problem. I would like to show the Hungarian situation because it's very typical for dry continental region. So here, the dark red shows the increased number of hot days. What does it mean, hot day? When the temperature is, the average temperature is above 25 Celsius degrees, so the peak is above 40. So it is very dangerous for the corn or the maize plant. And there is a long-term weather forecast that during the next 30 years we will have plus 30 days, 30 hot days. So within a summer, within 3 months, we will have plus 1 month hot days. It's awful. So it means that the corn is in danger. But there are other aspects of the weather climate changes, the weather changes, because the weather forecast shows that during winter time we can expect higher precipitation, plus 15 to 20%. So our government have written in a very important strategy in a document that we can expect higher yield of the winter crops because of the higher winter precipitation during the next decades. That is the reason why we are working with double cropping. which has two important forage sites, the corn silage and the winter crop. So, what happened during the last 2 years in Hungary as a dry continental region? We had a very, very low rainfall during in June in 2021. The precipitation was 16 millimeter in 1 month. It is awful. And during the whole summer, we have much lower precipitation as we expected. And it was just one side, because it was just the low precipitation, but there is another side that we had hot summer in the same time. So we had extremely high number of hot days. Altogether, 38 hot days we had during that summer. It is a disaster for the corn. And after, we had drought during the next fall, winter, and early spring. So we were not able to, the soil were not able to fulfill with water and to keep the water. So it is very dangerous when we haven't got rain even during the winter, fall, and springtime. And after 2022, we had an extreme drought stress, and because of the low water content of the soil, high temperature, and low precipitation. 2 years, the last 2 years. So that's why I prepared this presentation for you. I would like to show you what happened with our corn silage during the last 10 years, last 11 years, and especially during the last 2 years. So I would like to show almost 5,000 sample analysis. These are NIR data. We use the dry NIR system in Hungary, and we have a Dutch background, so maybe it's not comparable to with the United States systems, but very similar. I hope you will see that we can compare some data to each other. So, at first I would like to show the yield, what happened with the yield. Look at low yield, dry, it is silage yield, not dry matter yield. Approximately 19 ton per hectare, fresh silage yield 22, and after 27, and last year we had 17 ton silage per hectare as an average. It's very slow. And you see that we started to reduce the yield, but after we realized the low yield in 2021, we had to increase the crop plants in order to maintain the forage bank. But this increase was because of the low yield of the earlier year. So, quality. This is the yield, you see. And what is my impression is, I think it's just 10, 11 years, but if we have 5 years, within 11 years, where we can't reach this 30 ton per hectare yield, is a problem. And we have to work on it, how can manage it. And we had 2 extremely bad years within 11. So it is not a climate change in the future. The climate change is here on our cropland. So, and you see now some data about nutrient content. Generally, we had 35-36% dry matter. We tried to keep the 35 as a target because of the we would like to maintain a good starch digestibility. But what is more important is the starch content. Look at. It's unbelievable what happened last year. So, look at. Last year we had 20% starch as an average. Generally we expect 30-35. Sometimes we have 40% starch content. So, the 20 is extremely low, and the deviation was extremely high. We had maize silage without any cob last year, many thousands of hectares. We harvest maize without starch, so with zero starch content. So the deviation is another issue. And look at, in 2012 and 2013, we had also rather low starch content. So we expect 30, 35, minimum 30, and optimally 35, 30, 40% dry starch content. But 3 years within 11, we had extremely low starch. It means that the diet became more expensive because we had to add extra dried corn or high moisture corn in order to keep the energy content of the TMRs. So it's very costly. It would be the target. Okay, look at the organic matter digestibility. The maize silage is the king. Many times I tell to my farmers, because the starch digestibility is always very good, and if forage contains 30-35% starch, it means that the digestibility of the organic matter should be high. But I would like to compare with other new crops, the maize silage. The new rice silage, the whole crop rice silage, has had 72% organic matter digestibility in my country, and this data based on almost 1,400 data. And look at the intensive high sugar grass silages. In both stage, the organic matter digestibility is more than 70%, so very similar to maize silage. And these organic matter based on cellulose, this is fiber mainly, because there is no starch in it. Alfalfa is a question. So alfalfa has rather low organic matter digestibility, so we had to change our consideration about the alfalfa, but it's not this subject, so next years I can talk about the alfalfa, because it's a very important question also. So ANTFOM, this is the fiber. You see that if we have low starch, we will have higher fiber content. You see the first 2 years and the third year. Of course, it's not unique. If we compare with other crops, the rice silage contain much more fiber, and intensive high sugar grasses contain also much more fiber than the average of the corn silage. With normal starch level. But if we look at the extremes, you see that the grass has similar fiber content than the corn silage without starch or with very low starch content. But for me, this figure shows that the maize silage is not the best fiber source for our dairy cows. So look at the digestible fiber content. Look at. So there is high variability, as you see, and you see that in a disastrous year, when we have very low starch, we can get very high digestible fiber content. So nowadays, we have extremely high milk protein and milk fat in our dairy herd because of the low starch, high fiber maize silages. So it is advantage in a disastrous situation. But we don't like this situation. The real fiber sources in our TMRs is the rice silage, early crop rice silage, and the grass silages. These two new silage, for us, these are new silages in cut in wood, contain 2 times more digestible fiber than the maize silage. So they are much better fiber sources for intensive high milking dairy cows. It is our experience. Okay, so the degradable or the digestible NDF is much lower in the maize silage compared to, for example, the whole crop rye. That's why they are very good pair, not just on the field, but in the TMR also, in the diet. So I summarize something what is not questionable for me, but maybe you will not agree with me, that the corn silage is considered not to be an optimal digestible fiber source for our intensive high milking dairy cows, and much worse than the early cut whole crop cereals or grass silages. Okay, and I would like to show something what we were talking about yesterday. Should we wait or not for higher starch content? It's always a question when we have problem during the summer. And of course, if we are waiting, we will have higher starch content. This is the starch content as a close correlation, okay? But what happened with the fermentable organic matter? It will decrease. It is a decreasing tendency. Why? Because of the lower starch digestibility and because of the lower degradable fiber content. So I have the same recommendation as Louis yesterday told, that please don't wait for higher starch content because you will lose fermentable organic matter, what is the real and most important for the rumen to produce microbial protein. Okay, and you see now some correlation data that if we have higher yield, we will have absolutely lower fiber content, lower fiber, digestible fiber content, and we will have less available organic matter in the rumen. And the starch has in negative correlation with the fiber, of course, but these are very strong correlations. And the fiber is also important, not just the starch. Okay, conclusion. So the prevalence of the extremely low yield and poor nutritive values with very high variability show that the corn silage is at high risk in the dry continental region. And that's why we need strategic plant management to manage this situation in order to maintain a safe forage bank for our dairy cattle and their production, milk production. What can be the options if you would like to increase the starch content? I think there is not too much options, just increase the stubble height. I will not tell the details. Of course, there are many sides of this question, but yesterday we were talking about, and for us, the double cropping. So we can remove the coarse silage in the diet. In some area, it will happen during the next 10 years, but not is the good way, I think. The combination with rye or grass of the corn silage would be a very reliable tool in our hand to manage the drought and heat stress in Hungary and to maintain the feed bank. And of course, irrigation. We can wait for the irrigation systems. It's very difficult if in the surrounding area of the farm there are 30, 40 owners. How can we investigate if we have to share our equipments with other owners? So it's not easy, and the milk is the water is limited in my country. So it means that irrigation will not solve the problem. It will help, but against drought stress is okay, but against heat stress, it can't be a safe solution. So that's why I think that the double cropping would be one reliable option for us to maintain our maize field. And aspergillus is another problem. It's just one question, what we can do. Our soils in the southern part of the country, because of the very high temperature, the soils are infected with aspergillus, and we have very aggressive strains in the soil. So each year when we will have high temperature during the summer, we should expect high aflatoxin B1 level in our corn and corn silage. And if you don't mind, I would like to give some words. It's very, very, very special. It's my opinion, and maybe you will not agree with me, but I would like to tell my motivation. The company where I am working is not a research institute, it's not a university, but my mission to help the dairy industry. And I would like to share my thoughts related to it. So, what is our response to this challenge as forage scientists in Central Europe? This? What we have done during the last 20 years as forage scientists? It's not so effective. Okay, we can ignore the real challenge. or we can work in our ivory towers, isolated. It's possible, but who will have the farms? Or we can wait for irrigation as only one solution, but it's not the only one solution. We have tools in our hand, and you are the persons who knows very well this kind of forages. The farmers do not know so much about this aspect as you. Okay, so I think we, forage expert, can take up or should take up this responsibility, and we have to have the tax-paying farms who pay our salaries, tax-paying farms, and we should give the answers, scientifically proved but practical answers for their questions. There's no other future for us, I think. And this motivation, I hope, we'll have for the younger generation. I try to share this motivation among my students because the next generation is missing. But who will produce my silage? But there are other problems also. Is there a life after corn silage? Who will give the answers? We have to. BMR, sorghum, and high moisture corn, maybe, but we don't know at the moment. Okay, what kind of crop rotation can be effective in dry continental region in Central Europe? Rye and corn, maybe not for everybody. Or triticale and after sorghum. What kind of sorghum? BMR PPS, BMR brachytic, BMR Meister rye, Sudan grass. Okay, intensive grass and sorghum can be another combination, but Italian ryegrass or Festulolium. We need more research trial and record it, scientific proven data to have the farmers in their decision making. Okay, whole crop triticale and forage millet. We try to work with the millet, and it can be one option or more also. These are very drought-resistant summer crops. Okay, and in Slovakia, 2 weeks ago, Slovakian nutritionists who live in Canada asked me about the INDF content in Central Europe of triticale and sorghum according to the different phenological stages, and I couldn't give the answer. I asked myself, oh my God, I don't know these data. Okay, I did, and what he asked, he is a practical nutritionist, okay? He asked me about the BMR sorghum INDF content in different growing stages, the PPS BMR, the Meister PMR, or the brachytic, and I didn't have the data at the moment. A Sudan grass, or Sudan grass and sorghum mixes, they are also very beneficial options. We started to work it. Or legume sorghum mixes. Okay, why? Is it important for us? Yes, because it will limit the dry matter intake. If we would like to increase the milk yield, we have to increase the dry matter intake. You were talking about it during the last 1.5 days. And the INDF is a limitation for the dry matter intake. So generally, we say that the cow has to feed 4 kilogram digestible fiber and not more than 2 kilogram INDF. And the INDF content, it depends on the forage type and the phenological stage at harvest. So it is our job to find out these data because we need this data in order to reach 30 kilogram dry matter with high forage ratio. Have you seen this kind of formula? I have seen that Canadian nutritionist had with sorghum, and I couldn't give any answer for his question. So I think we should talk about, and we should make workshops in Central Europe. Who can do this, who can work on it, or who can make proposals for it? So there is a movie about the cow future, 2036. We will not have cow more. It's a futuristic movie. But no, it's not a funny question. The cow is the enemy the cow will destroy the planet because of the methane emission. Who can protect the cow? Okay, drinks. Now in Hungary, the oat, rice, coconut, and almond drink has similar price than milk. It's a very dangerous situation. Who will protect the cow and our forages? Environmentalists, politicians, farmers, or we? Who? Do we have responsibility? Yes. In Central Europe, absolutely. And why? Because more forage produce more methane. Okay, what we can do? We should feed less forage. It can cause acidosis. From animal health point of view, it's not a good option. Okay, we can use more fufu dust, white powder, to degrade the methane emission. But don't forget that the better forage digestibility will decrease the methane emission. There are many papers on it. And that is our job, to find out how can we give this kind of options and recommendations for the farmers for their decision making. So what type of forages they have to grow and when they should cut it to have highly digestible forage. And the last slide, I read this sentence on the Dairy Progressive in 2021, saving the earth with better fiber digestibility. So it is my take-home message. And I have to say thank you for your attention and listening to me. It was very personal, but I hope it was not useless. Thank you very much.
Thank you, Sylvie. Any questions? So I will ask the first one.
I didn't keep that time, I know. But I promise the next will be much shorter.
Are you sure? Anyway. When a farmer approaches you in a drought or heat-stressed year about when he should harvest his maize, what is your answer?
In drought stress. It's not an easy question. It's very important when the heat threat is coming in June, July, or in August. And how long is it? Because if we have 40 Celsius degree for 1 week, it's not a question. We have to cut because the maize will die. If more than 30% of the leaves died, so it's yellow and has a special figure, in that case, I suggest to start the harvest because on the dead tissues, the molds start to grow. And if we are waiting, the maize will not regenerate, but we will have a higher mycotoxin level. So when there is strong heat stress, unfortunately, I have to say that cut it, and after you have to replace somehow the missing yield, and you have to replace somehow the starch.
Thank you. Any questions?
Silvia, many thanks for this very important talk. We speak in our institute sometimes also of task for soil protection. So it's a kind of important things to have best water availability. Yeah? Are there strategies in Hungary to protect your soils? And what are the main goals here for?
Okay, thank you for the question. It's a beautiful question. So I have to say that we have done much more for our soil health than environmentalists in Hungary, because the double cropping has positive effect on the soil. Okay, the first crop uses a lot of nitrogen, but it covers the soil from September till April. And this covering will decrease erosion, deflation, and nitrogen leakage. It means that it has positive effect. And as I know in France, maybe the farmer has to keep always cover the soil. I don't know whether it's true or not, but I think it is my dream to cover always the soil, because we destroyed our soil during the last 40, 50 years. The structure is not good and the humus layer is very small. So the winter crops, the cereals and the grass can help us to protect against erosion and deflation, but I don't know other aspects. So in America, in New York State, the Cornell University was working on it, and I try to follow them because they have huge investment related to environmental sustainability and double cropping. So I hope they will have more data and we will understand more what is the advantage and disadvantage of the double cropping from the soil point of view, because I am sure that there are disadvantages. For example, the nitrogen is a question, because we have to give more nitrogen for rye and for the first crop than generally. Especially the grass need more nitrogen. Thank you.
Would you like to do your next presentation?
Yeah, I would. So the next presentation will be about the CSPS, this corn silage processing score. I think we was the first country in Europe who started this, installed this method, and now we give this data as routine data. So we can give the CSPS, the corn silage processing score, within 24 hours to the farmers. So we can give answers within 1 day when they start the harvest of May. I think is a very important point of view. So corn silage processing, what is it? The corn cracking is important, because if you don't crack the seed, Louis yesterday told that if you don't crack the seed to 3 parts, there won't be enough time to digest the starch in the rumen from the fragments. So we need as small fragments as possible. And the chopper harvester can make this cracking. And there is an American method Professor Mertens developed in Wisconsin University. This is the rotop sieve shaker. This is a very simple sieve shaker, and we use dried, but not ground, of course, dried maize silage samples. We shake it, and after we separate the different fractions. And what is CSPS? Is the starch content of the in the fragments smaller than 4.75 millimeter compared to the total starch content. So the starch percent in the small fragment, in shortly. So these are the rollers in the chopper harvester which crack the seed, and these are the standard values. So when the CSPS is more than 70%, so 70% of the starch are in small fragments, it is optimal. Between 50 and 70% is adequate, but below 50 is not acceptable. So we have the standard, we have the technique, the method, and the standard. And we started to work on it in Hungary because we realized the importance. If we have a smaller gap between the rolls, we will have higher starch digestibility. I'm talking about this gap here. Louis have found that if it is 4 to 8 millimeter, what is very, very big, we will have approximately 3% higher digestibility. If we reduce the gap between the two rolls, we will have plus 6% digestibility. And Professor Ball have found that if we have a well-processed silage, we will have higher dry matter intake, we can expect higher starch digestibility, and a better lactation performance. Okay, Professor Schwab had a figure about the non-cracked maize silage starch digestibility and the cracked maize silage starch digestibility, and you see the difference. Generally, we are working in this range when the dry matter is approximately 35%, and you see that there is difference between the non-cracked and the cracked maize silage starch digestibility. You see, here is the processed silage and the unprocessed silage starch digestibility. And you see, it's not just significant, but considerable difference. So, but the fiber starch digestibility depends on the dry matter content also, not just the CSPS. So this table shows us what is our target, between 30 to 35% dry matter content, above 70% CSPS. We can close to 100% starch digestibility. Maybe these data are not absolutely correct, but shows that we are close to the optimal digestibility. So it's not optimal. That is when we did not crack the seed, but we have very small chop size because the farmer believed that the smaller chop size will help to break down the seed. You see, it did not happen. So it's a very poor silage. And what will happen? What is the reaction of the cow? The seed we can find in the fishes. If we wash the fishes, we can find a lot seed. The milker on this farm collected the seed and he used for geese feeding in their home. So it's impossible, the loss what we can cause with, because of the non-well-managed processing. So Lewis has beautiful data about the losses. So we have data, as I think it's important that we can compare. So if the fishes have 5% starch content, we have just 94% starch digestibility. We lose 400 grams starch, and we need approximately 0.08 kilogram corn to compensate the missing energy. And at the moment, it is 15 US dollar cent per day per cow. So we can calculate the losses if we measure the fish's starch content. And there are mobile NIR systems to do it. If we have +1 starch content above 5% in the fishes, it will reduce the milk yield by 0.35 kilogram per day per cow. So the target is 3% starch. It is a Dairyland routine recommendation. So it's not a scientific data. Americans try to keep this %. So technology, how can we process the seed? There are traditional rollers. This is the shredlage. It's a new type of conditioner. Rollers, and this is the John Deere development is the kernel star system. But of course, there are many other type of rollers, and these rollers are behind the cutting blades. So it is the place where there are. It means that between the two rollers, so through 1 millimeter gap, 1,000 ton chopped material should go through within 10 hours. It's a huge, it needs a huge energy, so it will increase the fuel consumption and it will decrease the speed of the harvest, the chopper harvester. So there are disadvantages, we know, during the harvest, but we don't want to lose digestible starch for 1 year. Okay, so what kind of parameters have effect on processing? There are many, many different parameters. I will not tell it. And it means that the farmers, the crop manager has to pay attention many different aspects. But the most important is the speed of the harvester, type of the rollers, and distance between the rollers. These are the most important, but there are other factors also which may have effect on decision making on the field. It's not an easy job. Okay, so we analyzed almost 3,000 corn silage for CSPS. It's a combination of rotap sieve shaker technology and NIR. And what we have found, when we started in 2013, we had 55% as an average. And we had 12% increase during the last 11 years. So now we reached the optimal level as an average. I am very proud of our farmers. And the service at Krone, John Deere, class, because it caused a competition. This lab method, that the data available, it increased the competition between the chopper harvester companies, and the service developed because we could check. Okay, so it is the distribution. Now we haven't, so the 3 different classes is not enough. We would like to make more differentiated, more details. So that's why we have 5 categories now. And you see that now we have just 4% unacceptable CSPS maize silage. And I'm very proud of this data. You see in a figure, so we have 62% very well processed maize silage in Hungary. Of course, it's not a countrywide photo, but we have a lot of samples, so it's very representative. So what happened? From 34% to 4%, there is an extremely huge decrease in unacceptable CSPS point, and we had an incredible increase in the technology during the last years. Okay. And we calculate, based on the CSPS, a modified starch digestibility and a modified energy content. And we calculate the losses of starch, the losses of milk, and cornfield, what is starch equivalent with the losses. It's very impressive for the crop managers. They realize the losses, and we give these data as a routine evaluation to the silage. And what happened? Starch loss decreased, milk losses, potential milk losses decreased, and starch equivalent cornfield losses, the lost income increased, potential income decreased. I'm very happy with this situation. It's a lot of money for the farmers, not for our company, but for the farmers. So conclusion, if somebody install this method, it will have effect on the dairy industry, and it can help to improve the CSPS of a country. It can be a monitoring point, and it is a monitoring point now in Hungary at harvest. We can give a modified starch digestibility, modified energy. So it means that, it means that we can give data for a more reliable TMR. So we can help to the nutritionist for better, in order to make a better formulation, better TMR. Now, sometimes, in some cases, it is in the contract as a quality threshold. So this new valuation system can help for the whole dairy industry, and it can reduce the losses, what is, I think, an important aspect. If we have such a beautiful chopper and very expensive chopper, we have to work with it in a proper way. We need a well-managed processing, I think. Thank you very much.
Thank you. I think we have time for one question, maybe?
Just 5 minutes late, it's not so.
15 minutes for coffee then. Be back here by 20 past.
Thank you.
So, ladies and gentlemen, we will follow with our lecture, and the first one will be your lady Bunk with lecture Effect of Corn Shredlage on Feed Qualities.
Yes.
It's yours.
Thank you. Hello. Welcome to my presentation. My name is Laura Bunk. I'm from Germany and I work as a teacher at the course of study agriculture at University of Applied Science, Osnabrück. And 3 years ago, I was a student and I wrote my master thesis about a feeding trail with shredlage for finishing bowls. And we investigated the effect of corn shredlage on feed quality, fattening performance, health, and carcass value of flag feed bowls. And today I'm here to present you the results. Here's my agenda. First of all, introduction, then materials and methods, the results, and then the main conclusions. Yes, I think you know that corn silage is a popular feed for cattle, so its use is widespread. Corn silage contains high concentrations of starch and physically effective fiber, so it delivers energy and physical structure. But since the beginning of maize cultivation for silage, we discuss about optimal chop length. The recommendation in Germany is to harvest maize with chop lengths of 5 to 10 millimeter. Why? Because then we can compact the chopped material well. However, for some years now, there is a novel method of harvesting forage maize. It is known under the brand name shredlage. The corn is harvested with longer chop lengths, 26 to 30 millimeter, and the corn is crushed with special corn cracker rollers. And it is advertised by class that shredlage has a more favorable structure and better digestibility. If you look in the journals, you find many feeding trails with shredlage for dairy cows, but not for finishing cattle. I only found 2 trails, which I've summarized here in this table. First trail, it was in Switzerland with about 30 cross-bred bulls. Initial body weight was about 170 kilogram, and they split these animals into 2 feeding groups. Trail group was fed with shredlage in the TMR, and the control group was fed with conventional silage. And the result was that animals fed shredlage tended to have lower dry matter intake, lower average daily gain than animals fed conventional silage, but surprisingly, slaughter yield was significantly higher. The other trail was in Nebraska with 288 steers. They were older. Initial weight was about 422 kilogram, and the steers were fed finishing diets containing 9% or 14% shredlage or conventional silage. So they had in total 4 feeding groups. And the result was that animals fed shredlage had significant greater carcass weight, average daily gain, and feed efficiency compared to animals fed conventional silage at 14%. But now I want to talk about our trail in Germany, what we did. We harvested maize with 2 harvesting teams at the beginning of September 2019. We used for conventional silage a class Jaguar 970 with a multi-crop cracker classic, 30% speed difference and 8 millimeter length of cut. And shredlage was harvested by a class Jaguar 950 with the special shredlage cracker, 50% speed difference and 26 millimeter length of cut. And the chopped material was placed in this, you can't see, oops, in this big silage clamp. And the shredlage was filled the one side, and the conventional silage was placed at the other side. Yes, and for compacting we used, okay, thank you. This was the silage clamp, yes. The one side filled shredlage and the other side filled conventional silage. Yes, for compacting we used 2-class Serion, and the conventional silage was rolled with a rolling weight of 18 tons, while shredlage was rolled with a higher rolling weight. It was about 22 tons. Yes, the feeding trail, it took place on a big farm in Münster-Amelsbüren, Germany. The farmer has about 1,000 bulls, and this feeding trail was conducted with 72 bulls over a period of 8 months. Initial live weight was 382 kilogram, and the animals were divided into 2 groups based on their live weight. So we had 2 feeding groups. The trail group was fed with a TMR with shredlage and no straw, and the control group was fed with a TMR with conventional silage and straw. Nutrient and energy content was comparable, and here you can see the barn. The animals housed in pens with fully slatted floors and rubber mats, and here you can see the formation of control and shredlage group. We had 6 pens for shredlage group, green, and 6 pens for control group, yellow. And in each pen there were 6 animals. Yes, data collection. It was a lot. Look only at the pictures. We measured density, temperatures, we analyzed corn silage processing score, we heard about it. We weighed the animals on day 0. This was the start of the trail. On day 64 and 176, we calculated feed efficiency, daily gains. We got the data from slaughterhouse. We washed manure 10 times with a 3-part sieve, and we used smokestack bolos for recording human pH over a period of 150 days. Yes, and we calculated feed costs. Yes, and the red ones, the results are presented in the following. Yes. Density. Before you look at the numbers, please look at the sampling plan of drill core points. We sampled cores at 9 different points, each distributed across the cut phase of shredlage and conventional silage. So we had 3 points, each in the upper layer, middle layer, and lower layer. And now, if you look at the numbers, you can see there was no difference. Density of conventional silage was about 224 kilogram dry matter per cubic meter, and of shredlage it was about 216 kilogram dry matter per cubic meter. So this was good. Here you can see density separately for each layer. In the photo you can see also the core sample points. I hope you can see it. I think it looks a bit like a piece of cheese. Also here in the critical upper layer there was no significant difference. It was about 183 and 182 kilogram dry matter per cubic meter. Yes. Then corn silage processing score, we heard about it. It was in both silages over 70%, shredlage almost 80%, so optimal kernel processing. By the way, I must say that we checked kernel crushing during the harvest very, very often. You can see at the photos. Yes. So we want also this result. Yes, then dry matter intake and feed efficiency. Over the entire trail, dry matter intake of control group was about 10.5 kilogram per day, and animal and of shredlage it was a bit lower, 10.2 kilogram per day and animal. I think it was noticeable that dry matter intake of shredlage group until day 64 was 0.7 kilogram lower than of control group. A reason for this could be the dry matter content of TMR. It was lower than that of control group. So dry matter content has here an influence on dry matter intake. Yes, then feed efficiency. It was similar between control group and shredlage group. It was about 6.7 to 1. Yes, then live weight. On day 64, there was no difference. Control group and shredlage group, it was about 480 kilogram. On day 176, shredlage group was a bit lower, but the difference was not significant. By the way, we did not weigh the animals after day 176 because they were too big and too heavy for our weigh scale. Yes, and it would be also too dangerous for us to weigh them. Yes. Yes. Then average daily gain, it was about 1.5 kilogram per day in both groups. So also no significant effect on live weight and average daily gain. Carcass value. This was really interesting because animals fed shredlage had numerically higher carcass weight. Sadly, the difference was not significant. Carcass weight was about 403 kilogram of shredlage group and 397 of control group. And the animals of shredlage group tended to have better conformation grade. On average, they received an R+. And fat grade was significantly lower than that of control group. Yes. Then fecal residues. For me, this was an interesting thing on the trail. We washed manure 10 times, and look only at the photos. I think you can see there a difference. Animals fed shredlage had fewer fecal residues in the top and middle sieve. And this photo was on day 232, but you must believe me, it was on all dates we did this. Yes, and in my opinion, this was an indication that animals fed shredlage digested the ration better. Yes. Then rumen pH, there was no significant difference. By the way, the number of animals was too low to validate statistically differences. Daily mean pH of animals fed shredlage was numerically higher, 6.5. Standard deviation was lower. I think it was interesting to see I don't know. Interesting to see was that none of the animals fed shredlage had a pH value of under 6.0. I think this was interesting. Yes, but there was statistically no difference. Yes, then feed ration costs. In total, we fed 6 rations, and the rations with shredlage contain no straw and also fewer concentrations of concentrates, so they were cheaper. In numbers expressed, cost saving was about 5 cents per animal and day, but additional harvesting costs of €1 must be taken into account. Yes, so at the end, maybe cost saving was about 3 cents per animal and day. Yes. Then my conclusions. First of all, compacting shredlage does not present any problems when a greater rolling rate is used. Then feeding shredlage had a positive effect on the carcass value of the bolts. Animals fed shredlage tended to have better conformation grade and significant lower fat grade. Feeding shredlage led to lower fecal residues in the top and middle sieve. The animals digested the ration better. Feeding shredlage allows the omission of fodder straw and the saving of concentrates, and it offers potential for reducing the incidence of acidosis. Yes, that was it. I hope you understand my English. It's my first presentation in English, so sorry. Yes. Thank you very much for your attention. Thank you also to all people who were involved in this trail. It was a lot. Yes, thank you to Klaas that I could be here. Yes, and if you have questions, you can ask.
Thank you very much. That was an excellent presentation, especially as it was your first and your English is better than mine. Any questions?
Hello. Thank you for nice presentation. I would have one question. If I saw it right, the age at slaughter was higher.
Yes.
Why it was that way, or?
Yes, here this slide. Yes, slaughter age, they were older, but initial body weight was the same at the beginning of trail. At the beginning of trail, the animals of shredlage group, they were also older, but initial body weight was the same between both groups. Yes.
Any other questions?
Maybe I missed it. Have you used any silage inoculant to preserve the silage?
Can you repeat it?
Did you use a silage additive?
No.
Did you use a silage inoculant when you made the silage? Did you use an additive when you made the silage?
Yes, we used an additive of Schaumann, yes. Yes.
So it was with Buchnerei.
Yes.
Okay.
We used.
Very interesting presentation.
Thank you.
While the effects on compaction are a bit conflicting to existing data in the literature, even from Germany.
Yes.
But anyway, you did a scientific trial. I would be careful in saying plus 6 kilos increase in carcass weight if you don't find a significant effect.
Yes.
Okay.
It was also only numerically.
Yeah.
Yes.
But then even basically
yes.
There's no difference. So
yes.
even the calculation of the increase.
Yes. Right.
Okay. And then do you have any explanation for the effect of the different harvesting techniques on conformation grade, okay, a tendency, and the fat grade?
Yes, I have an explanation. Because dry matter intake of bolts fat shredlage was lower, and also energy intake was is automatically lower, and so maybe fat grade is also lower. Yes. So feed intake and energy intake, this could be the reason. Yes.
One more question?
Please, according me, the advantage for the shredlage is 2 points. One is the crash of the grain.
Yes.
Yes, but you tested and the result was the same.
No, corn silage
it's only
processing
5
score was
only
better.
5%.
It was better.
It's not too much.
It was almost
different. Was very little.
Yes.
Very little, yes.
Yes.
And second one point for the shredlage is spreading of the stover, yes, and increasing of the digestibility of the NDF. If you test it,
No,
because
no, it was a practical farm. We had not so much money to test it also.
yes, because this point is for shredlage very important
Yes.
point.
Yes.
Increasing digestibility,
Yes.
yes. And problem is that you have two silages and result is similar without
Yes.
differences.
That's right.
Thank you very much for
Okay.
your presentation.
Thank
and
you.
I would like to ask next lecture will be about portable nurse equipment, and speech will from Eisner and Sommer doctor.
Good afternoon, ladies and gentlemen. Good afternoon, the moderators. It is a pleasure for me to present my work here. We had a lot of very interesting discussions, and I hope it will be it will be one of the good discussions here as well. What I want to present one project comparison between two portable NAS systems and veg chemistry analysis in grass silage made at two different dry matter levels, and interaction with usage of silage inoculants. So the objective was to evaluate the efficacy of two inoculants of different mode of action on fermentation and aerobic stability of grass silage prepared at the low and high dry matter levels. And the second objective was to compare the results from veg chemistry analysis with the results from two portable NAS equipment in fresh silage and aerobically unstable silage after 7 days at aerobic exposure. We did the trial in the north part of Germany. We harvested grass from the pasture, and the grass was slightly wilted, wet grass silage, and 2 days wilted in the field, dry silage, and the silage was prepared in bales without any inoculant, with inoculant containing only homo-fermentative lactic acid bacteria and inoculant containing the mixture of homo and heterofermentative lactic acid bacteria. We storage the bales 65 days dry bales and 92 days wet bales. Why the storage period was different? Because of capacity of the lab to make the analysis later. We sampled the bales, and we sent the samples for veg chemistry analysis, and at the same time we analyzed the samples with NIR. And samples from the bales were incubated at room temperature in the special aerobic cylinders for 7 days, and after 7 days we analyzed the silage again, veg chemistry, and using these portable NIR systems. And statistic was PROC-GLM model including treatment, equipment, and their interactions as effects. So how we did, so the dry matter was analyzed in the lab, corrected for volatiles. The crude protein was analyzed in the lab using Dumas method, ash by ashing at 550 grad Celsius. And the same parameter we analyzed using two NRR systems, and we use the calibration curves provided by manufacturers. So they provided us the curves for grass silage, and we just followed the instructions. So it means per treatment we had 5 bales, and we took the samples from these 5 bales. And these 5 samples were analyzed with wedge chemistry. And then we had to incubate the samples at aerobic exposure. The problem is to get enough material after aerobic stress. We had to split the samples to 3 sub-samples because we could not. The equipment was that we could put only the small amount of the grass in these cylinders for aerobic incubation. So it means after that we had to collect, to mix the sub-samples again to get enough amount. It means 3 sub-samples from each repetition were prepared for aster incubation, and these 3 sub-samples were analyzed by 2 NIRs at J0. Then we averaged the results from 3 sub-samples to 1 to get again 5 repetitions, and then we compared it statistically to get 5 and 5. So after 7 days at aerobic exposure, we had these 3 buckets with the samples. We analyzed each of them with NRRs. Then again, the results were averaged, and the subsamples were mixed together and sent to the lab. So finally, we had again 5 and 5 repetition per treatment, per dry matter level. So, and here are the results for wedge grass silage. This is the control, untreated homolactic bacteria, homolactic and heterolactic bacteria. This is lab wedge chemistry. This is equipment A. This is equipment B. As you see, both equipments overestimated the dry matter content. If you look for crude protein, it is even nicer. If you can say the real crude protein was around 14–15% dry matter, one NRR gave us more than 20% crude protein in dry matter. Another was a little bit closer, but it was still overestimated. And interesting that we have this interaction between inoculation and equipment. It means we have the risk that equipment can deliver different values if we have inoculated silage or not inoculated silage. So it means we have interaction between equipment and inoculation. For example, here. Here it was 21, here it was 18.4, here was again 21. Yeah? But the real value was 14 in the control, 15 in the homofermentative treatment, and also 15 in heterofermentative bacteria. The ash is even, also interesting. Control had higher ash content, we can say, assume the real ash content, than the treatment because of less dry matter losses during fermentation. So I can say, no, higher dry matter losses. Inoculation resulted in less dry matter losses. If we have less dry matter losses, we have less organic matter degradation, which means finally we have less ash than in control. And here we see that we don't have any differences between only homofermentative lactic acid bacteria or the mixture of homo and heterofermentative lactic acid bacteria. Equipment A didn't show us any differences between treatments. Equipment 2 overestimated ash content again. So this is fresh silage. Fresh dry silage. The dry matter content was around 45%, And here the situation is much better. For example, we don't have any differences between equipment. It means equipment measure dry matter content good. For crude protein, for example, NIR-B showed similar results to the wedge chemistry. NIR-R still a little bit overestimated crude protein content. And for ash, NIR-A again overestimated ash content. No differences between treatments. And again, significant interaction because, for example, NIR-A showed the different results and NIR-B showed also the different results compared to the real value if the silages were inoculated or not inoculated. What happens if the silage is aerobic unstable? Only one treatment gave us unstable silage. It was homofermentative acid bacteria, wet grass silage. This silage was unstable. This silage showed significant increase in the temperature after 7 days at aerobic exposure. This is why I show only these results, because other silages were stable for 7 days and the results were very similar with the fresh silage. If the silage is unstable, we have organic matter degradation. It means we have water accumulation in the silage becomes wetter. And very nice, all methods showed the decrease in dry matter content. Very nice observation. Crude protein was not differed after 7 days if analyzed with fat chemistry. Interesting was that both portable and NIRs showed us the decrease in crude protein in aerobically unstable silage. And the ash, organic matter degradation, water accumulation, and ash content is increasing. We see it using wedge chemistry. We see it if we used NIR-A, but for example, NIR-B showed us decrease in ash content was completely not logical. Yeah? So the conclusions from this project are results showed that the values measured by NIR were closer to the wedge chemistry results in grass silages at the dry matter level closer to the optimal. The significant interaction between inoculation and analysis method for some variables indicates that the measurement accuracy of portable NIR could be affected by treatment with silage inoculants. Portable NIRs equipment may not deliver reliable results if the dry matter content of forages moves too far away from the standard conditions to the extremes, or the silage is aerobically unstable. It means that calibrations based on data sets, including a sufficient number of silages in the low and the high dry matter levels, and in different stages of aerobic iteration, are required to make this technology useful on a daily basis. Thank you.
Thank you very much. Any questions?
Hi. Did you correct the dry matter? Hello. Did you correct the dry matters for volatiles?
In the lab, yes, the dry matter was corrected for volatiles. Okay. Yes.
Yeah.
Okay, question about the accuracy of the portable equipment.
How many samples do you use for calibration?
I have not used any samples for calibrations. In one case, we bought the equipment, in another case, we leased the equipment, and we bought the calibrations from the producer of these NARs.
Okay, we are breeding, if we calibrate some near-IRS equipment, we use around, to be very accurate, the curve, around 5,000 samples, yeah, and to compare with the chemical analysis, and then the curve is very accurate, yeah. Therefore, just, you mentioned, just it's not reliable in if you use the equipment near IRS, yeah. Just the question about accuracy of and calibration, yeah, and the correlation.
The question is, if I buy an AI equipment and I want to use this equipment on my farm, I have to use any calibration. Yes, I cannot create my own. I buy this calibration. And finally, I have a grass silage that has 15% dry matter, and NAR gives me 20% dry matter, 21% dry matter. I cannot say this calibration is precise enough, at least for my farm. And if I recalculate this difference in soybean meal that I potentially could save, it's a lot of money.
Sure. Thank you. I think the problem with the handheld NIRs is that most of them come with preset calibration. Like you said.
I'm quite puzzled by one of your major findings, and this is that silage inoculants have an effect on the NIR result. Just a second, please. And I'm just wondering, NIR is measuring some chemical parameters. And I wonder if you would have an explanation why a silage that was treated with an inoculant behaves differently.
I don't have explanation. The question is this calibration course, what kind of silages they use? Yeah? So we don't know if the silages were treated or the silages were not treated. We know that with the treatment, sometimes we have differences in the fiber, for example, fiber quality. Yeah? So we can change it. Yeah? Sometimes we know in trials that we get the results from silages with a similar analysis, but these silages behave differently in the cows. Yeah? So I don't have the real explanation, but I say it is only indication, it was only one trial. Yeah? So. And the differences were, generally this interaction, it was statistically significant, or if it is from practical value, it's already another question. Yeah? From practical value was the absolute difference between chemical analysis and NR analysis. And in some cases, if the silages are more or less an optimal level, fine, similar results, but if the silages were too wet or aerobically unstable, the difference were there. Yeah.
Thank you. I think we need to move on to the next speaker. Thank you very much.
Next speech will be from Dr. Mitrík from Schaumann Company. No? Fill up. Sorry.
Okay, hello everyone, my name is Mitrík. I'm from Feedlab Company, and I would like to show our results from our work in propandiol in maize silages. The aim of our work was to monitor and evaluate the dynamics of the product of the propandiol and also other fermentation metabolites such as propandiol, also ethanol, 1-butanol, 1-propanol, and also the volatile acids in whole plants with different maize hybrids using 2 combinations of heterofermentative lactobacillus and homofermentative lactobacillus. The materials and methodology, we monitor the changes at the following levels. We had seven different silage maize hybrids. We had 2 cutting technologies with total length cut with 5 millimeters and roll gap 3 millimeters, and total theoretical length cut of 22 millimeters and 1 millimeter roll gap. We had 4 points of vegetation development in over time of 34 days. So we had 4 points of cutting. You can see here the calendar day. So it was around from half August to half of September. And we had 3 lengths of fermentation process, 90 days, 150, and 240 days. The fermentation analysis, we had done on it on ultra high performance liquid chromatography, on high-plex H, on this mobile phase, flow rate, and so on. Lactic acid and volatile fatty acids we measured on UV vis detector, and alcohols, propandiol, and also 1 butanol and propanol was done on RI detector. Other nutrients, they were measured on NIRS. We measured in dry stage after 2 millimeter sieve with SM100, and after that we melt that material on 1 millimeter sieve. Here we can see the calibration of our laboratory and R square value, and also root mean square error of calibration, and also the root mean square error of prediction here for the all nutrients what we measured. Our focus was on the Lactobacillus buchneri to find the way how it is produced. And here we can see the pathways of this strain to produce propandiol. This way is the most likely to be done. And also, with combination with Lactobacillus dealeruans, it could produce propionic acid or protanol and also ethanol. We had 3 groups. First one was the control group, so it had no inoculant, only epiphytic microflora. The first group was inoculated with Bonsilage fit M, which had Lactobacillus buchneri, Plantarum, and Rhamnosus. And the second one was with Bonsilage speed M. They had the same Lactobacillus buchneri, the same Rhamnosus. The one only different was in Lactobacillus dealeruans, and that speed M doesn't contain Lactobacillus plantarum. So it had the same buchneri, and we will see what it is done. Here you can see the 7 hybrids on the trail in 4 repetitions, because we had to cut them on 4 vegetation stages. We collect the material with class. Here you can see the pile, and here you can see this pile is the same hybrid with different type of cutting. You can see the differences. Here is the shorter one, and here is the longer one. So visually it's different. The silaging was done with vacuum machine. After we inoculate the material, we put them in the bag, into foil, and then into the vacuum for 1 minute to get the layout stick with the material. It was nearly 10 seconds under vacuum to get the minimum of the air inside. You can see in a minute how it will look. So perfectly stretched material. And after a few hours, the bags look like that because of production of CO2. And you can see there are a lot of bags. The storage was here in stable conditions, 20 to 24 degrees of Celsius. And here are the results. Here are the control group, first group with bone silage with M and bone silage speed M. The first note, all nutrients are in fresh matter. So in dry matter, we had 168 samples in each group. The dry matter was almost the same, so the start point was the same for each group, and you can see the differences. The control group does not contain any propandiol. The bone silage fit M had 4.9 grams in fresh matter, so it's quite a lot. And the bone silage speed M also produce some amount of propandiol, but not so much. The interesting is also the ratio lactic acid and acetic acid. In bone silage fit M, it's almost 1:1, so it's typical for heterofermentative process. But speed M produced much more acetic acid than the control group. We also measured ethanol, and it was the highest in the control group. So we can say that that material which is not inoculated with any inoculation, it could produce the much more ethanol than in inoculated groups. We also measured the propanol and butanol, and it is also important to notice that all the numbers are average of 90 days of fermentation, 150, and also it contains harvesting technologies. So it's average of all of these parameters. So we noticed statistically significant correlations between propandiol and lactic acid, acetic acid, and also ethanol. And preparation 1 with bone silage with M has the lowest lactic acid content, the highest acetic acid content, and also the higher ethanol content than preparation number 2 in bone silage speed M. So it also means that the pH was the highest in the bone silage with M because of the lowest lactic acid. Okay. Here you can see the preparation with number 1, results with preparation number 1, so it's only with bone silage with M. We divide all replications on dry matter into 8 groups. You can see here the differences. And you can see that the highest propandiol was in group number 2, where the dry matter was 25%. But it is not the best way to do the silage because of the loss of silage juices. But the highest peak was in this group number 3 and number 4. So it was 5.8 grams and 4.7 grams. Also, it's in a fresh matter. It is important to know. Here is the graph of the previous table. So you can see here that here is the peak of production of propandiol, but also here's the peak of acetic acid in the fresh matter. So it's not ideal for the intake of the cows. But here is the ratio 1:1. It's good for the aerobic stability, also for intake, and also you can get almost 5 grams per kilogram in the fresh matter. And it is from 168 samples. And afterwards, after 45% of dry matter, the propandiol was not going higher, it was going lower. So, conclusions. Lactobacillus buchneri strains was able to increase propandiol production almost 3.8-fold under the same condition, with combination with 2 homofermentative lactobacillus strains. Combination of 2 homofermentative lactobacillus strains, Buchneri and deliverance, with 1 homofermentative, Rhamnosus, did not produce increased amount of acetic acid. And Lactobacillus buchneri strain in production of propandiol depends with great probability on its action in combination with other Lactobacillus species. So the preparation number 1 demonstrated positive influence of production of propandiol, average content 4.9 gram in fresh matter. Preparation number 2, average content 1.43 in fresh matter, but higher than in the negative control. So the results of this work significantly indicate that the nutrient characteristics of silage hybrids in individual vegetation stages can create different fermentation starting points for course of the silage process. So it will require further monitoring and experiments, and this is just the one point of view for whole work. So the whole article will be published in several weeks, I hope. And here's the name of the article which will be published. Okay, thanks for your attention.
Thank you very much. Any questions?
Yeah, thank you very much for a really nice presentation. So I have one question regarding analytical procedure. The acid quantification you did at UVV's detector and
Yes.
not with RE detector.
Yes.
That could be a tricky because you have proteins that will interact at UVV's detector. So the quantification of acids could be a tricky. Maybe it's not correct. You should check the
yes.
RE detector.
Yes, I know, but we have, I don't have there. The sample was pre-treated with Cares indicate, and we modify it for the
Protein precipitation.
for liquid chromatography. So it was qualified, and after cleaning of the sample, it was possible to detect.
Because as you can see, your values for acids in
Yes.
whole plant corn silage are rather low. You have the lactic acid contents of 2%.
But it's in a fresh matter.
It's in fresh matter,
Yeah.
okay. Okay, that's it.
Thank you for presentation. This practical question, how you, because at first days of fermentation is release many gas production is big, yes?
Yes.
How you spend this problem, please? Maybe I miss, maybe you tell about that.
We had this problem. Some of the bags was like going to blow, so we need to flow the CO2 out and seal the bag again under CO2.
But it can influence the fermentation profile or not?
I don't think so, because it was still in the CO2, under the CO2 conditions.
Thank you.
Okay, thanks.
Please, did you show us the storage room for the silages, yes?
Yes.
But but I would like if you measure temperature during the fermentation.
Here.
If you measure temperature of storage during the fermentation, because fermentation was very long and usually temperature is changing.
So it was in a laboratory in one room when was the temperated temperature. So it was in this ratio 20 to 24 degrees.
I'd just like to make a comment. I've had experience in rooms, and the bottom can be cooler than the top, so you need to make sure you've got representative mixing of the sample so that you don't get a temperature effect. Any other questions?
Yeah, maybe the difference between the two inoculants, were they just because of different Buchnerie content? So how high was Buchnerie content between A and B?
It was here. Oh, okay. Here. I don't know.
Right. Thank you very much. Very quickly, Mr. Václav.
Yes?
It's total 21 scientists.
Yes? Yes.
How long do you prepare this one?
As fast as we can. But
How long when you start and you finish?
All on the same day?
yes. But we harvest the 7 hybrids. We harvest them in one day, and after 7, we harvest in these points, 7 hybrids, then 7 hybrids, 7 hybrids, 7 hybrids. So we have 4 points of vegetation.
Thank you very much. I think we need to move on to the final speaker.
Okay, thank you.
Thank you very much. And now the last presentation, and I would like to ask Dr. Illek.
Dear Chairman, ladies and gentlemen, the aim of my study was determined of concentration of mycotoxins in maize silage from different farms and to evaluate the health status of dairy cows, milk production and reproduction. The health status of dairy cow, in particular the incidence of subclinical mastitis, laminis, metabolic disorders and reproductive disorders, was monitored on 2 farms with above limit mycotoxin level in maize silage and on one farm where mycotoxin levels were low and below the limit value. We considered the limit value for deoxynivalenol to be 5,000 micrograms per kilogram, for xylenol 500 microgram per kilogram, and T2 toxin 100 microgram per kilogram. In the 3 Holstein herds with average milk yield of 10,000 to 11,500,000 performance, milk composition, laminis incidence, fertility, embryonic mortality, and metabolic profile were monitored. The diet of lactating dairy cow cows was the same in the 3 herds studied and consistent of my silage at 26 to 28 kilogram, alpha silage 8 to 10 kilogram, and concentrate plus minerals and vitamins supplements. Samples of rumen fluid and blood we collect from 10 cows in each herd and analyzed. Results. Farm A, B, C, and concentration mycotoxin. A, B, C farms. This is very low and this is very high concentration mycotoxins. Dairy milk in this farm 32, 30, 34. And somatic cells is very big different. See only 160. This is more than 300,000 per milliliter. Lamines 28%, pardon. (32) and only 6%. Conception rate 36, 32, 44, 45%. This result is this difference is significant. Rumen fluid, to some different, special in propionic acid, in this only 70.8, 50.6, and farm C 24% propionic acid from all volatile fatty acid. The same is lower than this. Butyric acid, not big different, not statistic different, and statistic different if number of infusoria, 28, 186, and 386,000 per milliliter. This is statistic very high, significant. Hematology, this is not big different in this group, and metabolic results is here. Total protein, not statistical different, albumin to same, no different is bilirubin, A6, and this only 4.36. This is hepatopathy. This is typical bilirubin in hepatopathy is bilirubin high concentration. To same changes, to same results in beta hydroxybutyrate. This is 0.94, more than 1, and number group C is 0.82. Aspartate aminotransferase, hepatic enzymes, to same different in this group compared with group C. Other metabolic is not different. No beta carotene is very low. This compared with group C. Vitamin E is lower in this group compared with number C. No, this result is this difference is not statistic. T4 in this very low compared with this group number C. Conclusion: increased concentration of mycotoxins in maize silage negatively affect the health of dairy cows. This was manifested by high proportion of lame cows and increased incidence of subclinical mastitis and impaired fertility. Mycotoxins had a negative effect of rumen fermentation processes, reduce propionic acid synthesis and reduce number of infusoria in rumen fluid. Feeding of maize silage with excessive concentration of mycotoxin negatively affected the metabolic profile of dairy cows. Liver function was impaired as evidenced by increased bilirubin, beta-hydroxybutyrate, and elevated aspartate aminotransferase values. Significantly lower serum level of beta-carotene, vitamin E, and MT4 were found. Thank you for your attention.
Thank you very much. Any questions? Now this is where I'm unstuck because it's well outside of my field of expertise, so
Thank you very much, Josef. Now I would like to thank for your attention and ask Mr. Dr. Jambor Václav to close this symposium.
It was the last speech. We spent 2 days, and I hope that the 2 days was active and that all was okay. All of you have these results, our meeting. All speeches, all posters are in these books. I hope that you have this one. If you haven't, we have other also. We took you this USB, and on this USB is also form this proceeding. For correction, for other, you can use for your college at your university and so on. Also, we have possible to send you screens of all these 2 days. And I have to say thank you of you. Very glad that you spent a lot of journey to here, for example, from Welsh, but somebody was the Mexico, Estela, and it's a very long time, and thank you all very much for participants. I saw the list of participation, and I have to say that total participants was 131 people. I think that good results, and I hope that we will sometimes remember for this today. And the last point is tomorrow. Tomorrow morning at 9 o'clock, we will meet here in front of the door, and we prepare 2 excursions. One excursion will be to museum, and a second excursion will be to breweries. Thank you very much, and I wish you a safe journey at home. Thank you very much.